tracing that you were shown, and it's a wide complex and a narrow complex. And the question that I have asked you, and this is not an easy tracing, by the way, the question I've asked you, is this a supraventricular tachycardia with and without aberrancy? Is this both a supraventricular tachycardia and a separate ventricular tachycardia? Is this one tachycardia that starts another, a concept called tachycardia-induced tachycardia? Or is this supraventricular tachycardia with bystander pre-excitation? Well, let's dive right into this and see if we can figure it out. First thing you need to do is accurate measurements. This is a classic example of measure twice, cut once, okay? If you were a carpenter, you'd understand that. Measure twice, cut once. Most mistakes of people who look at this tracing are too quick an opinion. So what I want you to do is to basically measure your A to A intervals. And if you do, you'll see with a tiny variation, they're spot on. So that's your A to A interval. And the activation sequence is coming up centrally. You're pretty much in the center of the heart, and you go out to the left and then on the right side. And you'll notice if you measure the ventricle cycle lengths, they're not the same. So if you look at the first three ventricular tracings here, that cycle length is distinctly different from the atrial cycle length. So if we go to our choices, you can't have SVT with and without aberrancy because you have two different rates. So that's off the board right away. It just can't happen, okay? So then what about the concept of a tachycardia-induced tachycardia? Because actually that's not a bad choice, but again, you have to measure both. Then for that to happen, you'd say that, well, this is one tachycardia, and I could tell you it's VT. Now, I'll admit sometimes you don't get the most robust hiss, but if you look, you'll see there's a hiss here, and there's a hiss here. It is there, and it's not here. This is the SVT portion. This is the VT portion. And you'll also notice that the RV catheter, wherever it was somewhere in the septum, starts around the beginning of the QRS, so it's somewhere in the septum. And I suspect many of you have seen at some point in your careers outflow tract VTs occurring at the same time or even sometimes starting an AV node reentry. Well, this is an outflow tract VT. If you thought that's what it was, you're correct. But it's not starting the AV node reentry, which is the diagnosis here, because the AA intervals are the same. So to start it, you'd have to have all of them being equal on one side the same, because it's going up retrograde, and then making a transition into the new rhythm. So it can't be tachycardia-induced tachycardia, okay? So we've ruled out tachycardia-induced tachycardia. We've ruled out SVT with without aberrancy. We're left with the concept of two separate rhythms or a bystander. Now, what about a bystander? Well, a bystander is not a bad call if there was one-to-one. So a bystander means it doesn't affect the tachycardia. So let's say you had an accessory pathway, but for it to be an SVT with and without a bystander, then you'd have to have the same rate of the V as the A. Same concept. It can't be a different rate. So guess what? It's not an SVT with a bystander. And even though you may not want to call it two things, you need to call it two things. This is supraventricular tachycardia. Turned out it was AV node reentry. In addition, at the same time, you have VT. And you need to know this, and you can figure this out often on intracardiac tracings from defibrillators. Sometimes you look real carefully, you think they're one rhythm, and you find out the atrial rate is different than the ventricular rate. You have two separate rhythms going on at the same time, so you can apply the same logic. Thank you very much.